All right, so what we're doing today is we're just going to continue talking about hypothesis testing, and now we're going to get more into specifics about it. So first of all, we need to remember what p-value is. And remember, p-value is that value that we've been finding from the normal CDF, right? And so the p-value is actually the probability of getting the observed result given that the null is true. And a question we need to ask ourselves is, how low is low enough? Well, it kind of depends on a couple things. The first thing, it depends on your belief in the null. Are you confident in data? If you're not then confident in data, then your p-value might need to be lower so that you can really see a difference. Do you trust the experimental method? Did they follow a procedure that is statistically sound? And the last thing you have to ask yourself is, well, did they follow survey protocol? Did they try and eliminate bias? Okay, so what does a low p-value tell us? A low p-value tells us that there has been a change. To find out what the change was, we run a confidence interval. To find that change, you run a confidence interval based on your results, not the original mean that you had for your null hypothesis. Because you reject it because it's a low p-value, to find the change, you're going to run a confidence interval based on the results you had, not the null hypothesis. Now, there's something called an alpha level. And what an alpha level does is it's kind of the threshold for you to set ahead of time for the p-value. The most common ones you're going to see are going to be 0.1, 0.05, 0.01, and 0.001. And so a good way to think about it, a 0.1 is it's not very important. Maybe you're asking about your favorite pizza topping or your favorite color. A 0.05 is important, but really a 0.05 is, that's where you go if you're in doubt. This is the basic, if in doubt, go here. 0.01, that's going to be for medical and other important things. It's a little blurry. One thing that happens with an alpha level is it must be determined before you look at the data, which kind of makes sense. Otherwise, you would pick the alpha level that works for you so you could reject or fail to reject based on what you're looking for. If you have a p-value that's below our alpha value, so if our data fails to have a p-value below our alpha, then we didn't meet it, right? And so the data failed to provide sufficient evidence. Evidence to reject the null. And that's where you're going to write your context. It's also a good thing to include your p-value. So when you say it's not an accurate or not a sufficient evidence, then include your p-value so that they can know what you were doing. One thing that's important is you got to think about your sample size. If it's too small, the data may have a low p-value, but it might be hard to tell because of the sample size. Remember, the larger the sample size, the more accurate things tend to be, and the smaller the deviation is. All right, last thing, statistically significant. When our p-value meets our alpha level, we can say that we found something statistically significant. Okay. All right, let's look at these problems over here. And what I'd like you to do is see if you can figure out what an appropriate alpha level would be. And when you're ready, go ahead and press play. So anywhere from a 0.05 to a 0.01. I probably would stick to a 0.05 because antacid, while it is important, it's not life or death. Death. Number 2, we're surveying high school seniors. Doesn't really matter. So, I mean, it matters, but it doesn't. So I'd say a 0.10. In the 80s, it was generally believed that congenital abnormalities affected 5%. And so for this one, that's pretty important. So 0.01, maybe even a 0.001. And then same thing for the last one. It's a medical one. So I'd say 0.01 or 0.001. All right. The next thing that I want to talk about in our notes is something called power and type of errors. So when we have errors, it's when you reject or you fail to reject incorrectly. So a type 1 error is when the null hypothesis is true, but we mistakenly reject it. An example of this would be if the jury convicts an innocent person. Another way to look at a type 1 error is that there's no difference. Nothing changed, but you think there is. No change, but you think there is. And when you think there's change, you're going to reject it. A type 2 error is when the null hypothesis is false, but we fail to reject it. So this is when the jury lets somebody guilty go. Type 2 errors occur when the null hypothesis is true, but we fail to reject it. This is called the beta. So a type 1 error when there's no change, but you think there is. And a type 2 error is when you don't see the change. So some people like to see the table. This is something the textbook had, so I wanted to include it. And so there's 2 options. If your alternate or your null is true or your null is false, and then you can reject or you fail to reject. Those are the things that can happen. Okay, if your null is true, then you are supposed to fail to reject it because the null is true and there was no difference. So this is what's supposed to happen. If it's true, but you reject it, this is a type 1 error. If the null is false, that means there's change, you're supposed to reject it, so that's okay. But when the null is false and you don't recognize it, that's a type 2 error. Okay, so let's look at an example and let's see if you can figure out what type of error it is. So take a second, you have this paper, it was part of your notes. Go ahead and read it and start off by writing the null and the alternative, and then state what a type 1 is and state what a type 2 is. So you should have said that your null was 68.3 and your alternative is that it's going to increase. Now, a type 1 error, remember a type 1 error is when there's no difference but you think that there is. So for a type 1 error, home ownership stayed the same, but you thought it worked, and so the city kept the tax break. So there was no change. Home ownership did not increase, but the city manager and the office thought that it did, so they kept the tax break. On the second one, a type 2 is when there was an increase of home ownership, but nobody noticed it. And since they didn't notice the change, they stopped the tax incentive program. Both of them are bad, and you could really say whichever one you thought was worse than the other. You just have to back it up. Okay, the last thing I want to talk about is power. Okay, with power is the probability, not supposed to be there, that we correctly reject the false. Okay, this line right here represents our alpha level. At the beginning, let's say we selected our alpha level to be 0.05. Okay, so if it's true and our p-value ends up over here, this is where we're supposed to reject it, right? Anything smaller than 0.5, we're supposed to reject. So this is the reject side. Everything to the right side of the alpha line, we're going to reject. If it falls over here, this is a large alpha value, and so we fail to reject. So everything on the left of the side is we fail to reject. So this first curve represents true null hypothesis. This curve over here represents false null hypothesis. Now, if the null hypothesis is false, I'm supposed to fail to reject it over on this side. This is the percent of time that we do it correctly. Because when it's false, you're supposed to reject it anytime there. And this in the center, this is called your power. Your power is 1 minus beta. Remember, beta is a type 2 error, which is right here. This is my type 2 error region right here. It's false, but I failed to reject it. And these together make 100%, so that's why it's 1 minus beta. Some things you need to know is if you want to increase your power, I can increase the alpha level. So if I slid this alpha level over to 0.10 now, this part would be highlighted also because it's slid over. So if you want to increase your power, there's a couple things you could do. The first thing you could do is you can increase the alpha level. Because if you have a higher alpha level, it's easier to do things correctly, and you're going to see more answers that work. And then the other thing you could do is you can increase your sample. Remember, increasing sample always makes the standard deviation smaller, which puts things closer together, which increases your power. So just some side things that we should know about the power. The higher the power, the more confident you should be. Okay? Power is based on the effect size. Okay? And the effect size is the distance between the null proportion and the true proportion. Distance between the null and true proportions. Really, if you have a large effect, it's easier to see. Smaller effects are harder to see. Okay? So, overall in this lesson today, we talked about the different, make sure you understand more about P levels. We also talked more about setting the alpha level. And then we also talked about type 1 and type 2 errors. You will not have a ton of problems that deal with power, but if a problem is asking you to increase your power, you need to remember to increase your alpha level to make it easier to reject something, or you can increase your sample size.